In this video, we're going to cover section 10.4 on the reactions of alcohols, specifically oxidation reactions. And as we've seen previously, we're going to be looking at ways in which we can take the alcohol and prepare via an oxidation process a carbonyl-containing compound. Now, the outcome of this oxidation reaction will really depend on the nature of the starting alcohol, whether it's a primary alcohol or a secondary alcohol. Now, a primary alcohol has two protons attached to the alpha carbon, and as a result, the primary alcohol can undergo the oxidation process twice. We can convert the primary alcohol first to the aldehyde, and because there's still one carbon-hydrogen bond remaining, we can further oxidize the aldehyde to the carboxylic acid. However, for a secondary alcohol, we only have one carbon-hydrogen bond. We only have one proton at the alpha position, so the oxidation process can only occur once, and the resulting product of that oxidation will always be the ketone. And tertiary alcohols is shown here that because there are no carbon-hydrogen bonds available for oxidation, we cannot oxidize a tertiary alcohol. It will remain as a tertiary alcohol under any type of oxidation process. Now, the most common reagent used to carry out the oxidation process is chromic acid, H2Cr O4. And this is formed in one of two ways. We can start from chromium trioxide in the presence of an acid and acetone, and this is sometimes referred to as the Jones reagent. Or we can prepare it using sodium dichromate, as shown here, in the presence of sulfuric acid and water. So I show you these various methods just so that you'll be familiar with the various reagents that are used to carry out this oxidation process. Now, when a primary alcohol is oxidized with chromic acid, what we obtain is the carboxylic acid. It's very difficult to isolate the aldehyde under these reaction conditions. So the presence of chromic acid, it will react very efficiently with the aldehyde to give us the carboxylic acid. And so it's difficult to isolate the aldehyde. So as a result, when we react a primary alcohol under these conditions, the product will be a carboxylic acid. Now, we're not going to look at the mechanistic details of how this oxidation process occurs. It is relatively straightforward, but it's lengthy. So if you're interested in learning more about the oxidation mechanism, by all means, we can set up a Zoom appointment to do that. Now, that's not to say that we can't produce an aldehyde from a primary alcohol. We can, but we must use a more selective oxidizing agent. We need an oxidizer that will react with the primary alcohol to produce the aldehyde, but one that will not react well with the aldehyde. And so the choice that we often will go to is the pyridinium chlorochromate, which is abbreviated PCC. And so this reagent will produce an aldehyde from a primary alcohol, but will not react with that aldehyde to produce the carboxylic acid. And so the major product will be the aldehyde. And we will use a chlorinated solvent like dichloromethane or chloroform to carry out this reaction so that we can solubilize the alcohol and the pyridinium chlorochromate together. Now, since secondary alcohols are only oxidized once to form a ketone, we can use either PCC or chromic acid to carry out that particular transformation. So we can use sodium dichromate in the presence of sulfuric acid and water, or the Jones reagent, chromium trioxide, in the presence of acid and acetone to carry out the oxidation to the ketone, or if we wish, we can use pyridinium chlorochromate in a chlorinated solvent as well. So we have a bit of a variety when it comes to secondary alcohols. So if you have any questions about the oxidation of primary and secondary alcohols, by all means, send me an email. Thank you.